Apparently, Scratch, like the kids programming platform. I mean, I say kids. Well, it is for kids because it's so limited. It's kind of stupid. The kids programming platform is adding AI features, and that's like the new big update. Instead of like actually adding like, things that would help people do more creative things. I mean, it's great because like Turbo Warp and Penguin Mod have existed for years now, and like Scratch just hasn't done anything. Like it's kind of tragic, because Scratch should be a really good platform for for kids to learn how to code, but like, first of all, it doesn't even like use programming concepts that you'd find in like Python, like even like so like Python is still the better language to start with because the way Scratch uses programming isn't particularly like, I guess it's like the right kind of like problem solving thinking. It's like it's still useful, but like it doesn't really give you a good model of how programming actually works in the real world. The real world. And it's also a shame that you can't really do much with Scratch either. Like Scratch has so much potential, as people have shown, to do some really cool things, make some really cool projects. But like the limitations within the website itself, and like within the blocks they give you, it sucks. Like it actually sucks. It's actually kind of terrible. It was great for its time, and then like a decade passes, and like they haven't improved it like at all. So that's unfortunate. And now they're adding AI features, so I don't know anymore. What the hell, MIT? But that's not what I'm focusing on today. Today I'm back on my spec. So yesterday's video was literally 7 hours, which was quite something. And in that video, 7.5 hours. In that video, I looked at language, but then I got sidetracked and kind of ended up looking a lot on my own language. So that's the wrong monitor. Yeah, so this so I'm working on designing a programming language because I don't like Rust that much. Unfortunately, I find the ergonomics to not be great, which sounds crazy to some people because, oh my god, there's tagged unions and there's traits, like, I guess, and the tagged unions are great, like really great, but they kind of just like copied it from from Haskell and called it a day. It's like there's just so many things in Rust that like could be better that aren't, and that annoys me. So C++ somehow is still the best language that I still prefer using, which is really frustrating because C++ is also really annoying to use for its own reasons, and it could definitely has ergonomic issues. So to really, because like I have so many projects I want to get on with. I want to make modding tools, I want to make a game, I want to make a programming language, but to do these things, it's hard when the language you're using, you just hate using it, because I'm a very particular person, right? I really struggle to do something when the tools I'm using are annoying to use. So like obviously I can get more grit and stuff, but like these things are just really hard to maintain. Like these projects are not small. Like they are big projects, to be fair. Like modding tools. When I say modding tools, I'm talking about like a whole like modding suite. That like handles like files across different games in the same engine. Like uniformly, and like you can do all kinds of things. Like that's a huge scale project. Making a video game, but like a proper like full scale video game. Of which I compare to like Plants vs Zombies, also a really difficult task that's like really big, right, and takes a lot of code and time, and a programming language also takes a lot of time, although that's what I'm tackling right now. So yeah, I need something better. The best innovation comes when someone is fed up with how things are currently done, or they have a idea for money, I guess. But I'm hoping that this can actually go somewhere and be useful to me. Even if it's not useful to others, even if other people look at it and go, this looks I don't like how this looks. Like, as long as I can use it, I'd be happy, because then I can actually make stuff, right? I need the tools. The human is making the tools, because that is human was designed to do, or at least evolved to thrive at. So this is the language. It has no name. It also has like no uniform syntax either. I'm still deciding things as I go along. So I'm gonna kind of split this up into different stages and blog posts, because I've been wanting to make a blog post for like different features I like, ideas I have for how a language can be designed, but it's hard to do yet because I still need to figure out all the things. Like, I wrote a whole thing about if statements, which may or may not be open here. Let me just close these as well. Oh yeah, I just finished the C++ documentary. I just realized I still haven't finished that video. Okay, so it was this. I should probably group them into a folder at this point, but unify if and match. So I worked on this. I mean, I've already talked about it in a different video, but this is like was meant to be a blog post, and it almost was, but I got stuck on the end, which is first of all this with else and the empty case, but the other issue was exhaustiveness. So I'm working on that. Yeah, here, exhaustiveness. And I really can't think of a good solution. So I need to revisit this. But I want to come back to this later, because before I can handle this, I first need to decide on the more basic things, like variables and functions, for instance. So if I go back to this spec, you can see I've got variables and functions here. You can see that functions, okay. You can see that functions can be mutable. They are assigned to like variables, right? And I'm not sure if I want to keep on this idea, but for now, this is what I've started with. Because the idea is that a function is just a lambda, right? And lambdas can be treated as values. So a lambda is an anonymous function, in the same way that a literal is an anonymous variable, you could say. And then when you assign it, when you give it an identifier, you're storing it, right? So that's kind of the idea of a function, and then having a lambda, and that's why I want them to be assignable. Because not only does it unify function declaration syntax with lambda syntax, but also just kind of like nails home the first class functions thing. But to figure that out, I also need to look at the type system, because then the type system says that functions can be values, so functions also have types. So then what do you want the type of the function to be, right? And then if functions have types, right, and can be passed around as values, what else could be passed around as values, right? Like, could structs be values that I can also pass around and give names and then modify? Can types be values, right? Higher kinded, or is it higher kinded types? Not really. Higher order types is what I'm talking about there. Because I want this language to really feel powerful, where it's there is literally an elegant solution to everything, if I can. And by elegant, I don't mean super short and succinct. I mean just the way it reads makes sense to whoever's reading it, and it isn't horrifically tedious to type out. Oh, also the errors. Yeah, the error handling also is another thing. My idea for error handling is something I've never seen in a language, and I'll explain it as this recording goes on. But I'm very curious if it would work in practice, because in theory it's very enticing. Where basically everything can be an error. Every value can be an error. And this works because the overhead is removed when the compiler can verify it cannot be an error under the circumstances of your program, right? So again, I will explain that as I go on. So the first thing that you will need to figure out when you're designing a language is, do you go functional or do you go imperative? Or rather, functional or procedural, right? And then the broader categories there are declarative or imperative. Declarative means what you read is what you... No. So declarative is like what the code you write is declaring what you want to happen, whereas imperative code is writing code that declares, well, I say declares, but that says that, you know, that instructs how you want the code to be carried out. Now, the line between these are like extremely thin, by the way. You can very much write like declarative style code in C++. It's called, you know, writing your logic in functions, because function names, like if I have a function called print, you know, I'm not saying how I want it to be printed down to the molecular level. Like, you know, I'm just calling my thing print, and therefore, look, now my code is declarative. So already that sort of thing. So really, declarative and imperative, it doesn't matter. Like, you just encapsulate imperative code, and then you get more declarative code, and like that's just kind of a natural thing. And then eventually we get to where we want, which is declarative code, which we can then look inside to see the imperative details. That's a good language, right? So as I say this, I should really be writing this down, right? So let me... Yeah. I need to think of a way to like really organize this, my thinking. And I think I need to use my Zelocaster as well as I go along here, because that'll be invaluable. So let's create a new note in my Zelocaster. For those who don't know what a Zettelkasten is, you can look it up. Zettelkasten. I've made lots of videos about it. It's basically like a note-taking thing. But yeah, so the line between declarative and imperative code is extremely thin. Any language that supports encapsulation of instructions, most commonly functions, will functions / procedures, well, named functions / procedures will offer a way to turn low level, you know, in instructive codes into higher level I say what I do. Well, yeah, declarative code. I mean, like, the word declarative, like, literally means I'm declaring this, right? I'm declaring that I'm going to print. Whereas imperative is like, you know, you are, well, it's like the tense, right, in English, the imperative tense. Like, do this, do that, you know, do these instructions. But, like, you know, same thing. I declare that you should print. I impere that you should print. I don't know if impere is a word, right? Like, to say print is literally imperative. Like, that's literally in the imperative tense. So, yeah, I don't know, man. But anyway, so it's instructive code. It's a high-level declarative code. For example, when I call when I call puts in well, okay, printf, let's say, in C, a language which is typically regarded as procedural and not declarative. I do not need to detail how I wish the printing to occur. I only declare that I want a printf to happen with the arguments I feed it. Right? really, the only language, the only family of languages that is truly imperative and does not support declarative abstractions is assembly. But even then, you can do things to make the code. Yeah, but even then, like the instructions are still, but even then, it's not like you're detailing things down to the molecular level. You still have abstractions, which are by all means declarative. So yeah, I mean it's not the same. Conversely, a language that is truly conversely, there are languages that are truly declarative, but to the point that they are barely even considered programming languages. These are the likes of HTML, XML, and CSS, right? Well, CSS and Markdown. You cannot program something without being able to list instructions in some way or form. Literally. So like if you're gonna make a programming language, it's gonna have it, right? My friend sent me a Skrillex song, a new one. I think it's called Thistle, and it has like Brazilian funk, like mixed into it. But then it's also like still like electronic. It's a cool mashup. There's a song called Chegao, or like Chegao 3. CHEGOU. I mean, you've probably heard it, but like it mixes house with Brazilian funk. And it's also really good. I mean, like Brazilian funk in general is just like very, like the kind of like beats it has, like do ta ta do ta, or like ta 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 ta. Like generally, if it's like a dancey beat, that has like a bit of like a more, what's the word, basically if it has a rhythm that like that isn't just boom 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 boom, then it's basically classified as Brazilian funk. Like the moment you make it more interesting, it becomes Brazilian funk beat. So naturally, if you mix that with other genres, you just get more creative things. Like let me try on like boom 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 boom. Like, oh no, that suddenly sounds Brazilian. Or if I go from boom 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 boom. Anyway, just put that out there. Anyway, so yeah, so declarative code is imperative code is declarative code. Topics, of course, programming language design. Well, not really programming language design, but programming and coding, which are two different things, by the way. I will say, specifically because HTML is code, but HTML is not a program. It's more of a spec, right? It's a specification for how you want your thing to look. That's different. Because it's literally saying like how to render things. Functional programming is not declarative because, I mean, it is declarative, but like it's still imperative because like you still have to feed it instructions, and like you need to have some kind of order. Like the moment you add that like that order of execution is when you have a programming language. So and the reason that like languages like HTML, XML, CSS, Markdown, the reason they aren't programming languages and you can't program them is because they do not give you a way to do things with an order. I mean, nor do they have like basic utilities like printing and whatnot, but like they're very much not programming. So okay. So this language therefore is obviously imperative, but it's also declarative because it supports high level constructs. So fundamentals, let's say. The fundamentals of our design. Oh, by the way, my laptop is in front of me here, like this way, but my monitor is that way. And the reason I'm looking at my monitor is because although there is delay on OBS, it just helps me keep my head up. In fact, I should probably just move my OBS to this different screen. Should I? I think I should. Let me do that. So let me move. How the fuck do I do this actually? Could move this to my second display. Nope. Move this to 2. Yeah. Move this here. Oh, but I'm sharing my other screen. Okay, never mind. I can't be arsed right now. So anyway, so fundamentals. The line between declarative and between a declarative and an imperative language is essentially non-existent. So essentially non-existent. Programming language. By the way, shout out apple, mango, spinach, avocado. What a combo, honestly. Yeah. Quite simply, this language. Well, okay. So there's an idea here. This language will allow you to abstract low-level imperative code into high-level declarative wrappers, such that you can peek into any function, into any procedure, and well, any named procedure, and see the underlying mechanisms at play. So something that's kind of been interesting to me is how languages like C, well, yeah, I mean like C for example, like C isn't written in C. The C standard library isn't written in C, which is very strange to me. Like obviously, like C++ has the template library, so that has to be written largely in C++. But like if I look at how much of the C standard library is actually written in pure C, because C doesn't have like structure. I mean, it has structs, but it doesn't have like classes, right? So there'll be a lot of things that are outsourced to assembly or like compiler defined, and it's like is it not weird that you can't define your language within the language itself? Like I find that a bit bizarre. So string copy, memory copy, often see sometimes assembly performance, critical paths, standard IO buffering logic, and lib functions like qsort, malloc, mutation logic. I mean those have to be right, like malloc, unless you but they don't have to be, because like C supports assembly, right, inline assembly. So even then, it's like I don't really understand. My functions in libm, and mostly C with some assembly things like square root on path functions with hardware support. Right, so it just calls the instruction directly. Well, okay, I'm guessing like inline assembly doesn't count as C. and that's why it's saying that. Syscall wrappers, obviously not. Set jump, long jump assembly, mem copy, mem set string variants. Okay. So why is it that not everything can be written in C? I get that you may want, well, I get that you need assembly to, yeah, I don't know, it's just like, yeah, I don't know, like, like you really shouldn't need assembly. Like the language I envision literally starts at the assembly level, machine code level, and then allows you to abstract on top of it, such that your print function, you could inside the language itself look into it and find the like machine level code, right? Now the issue with that is different platforms, right? And the compiler may want to optimize things in different ways. But like even compiler optimizations, like can those be defined within the language itself, as opposed to being like something the compiler figures out? Is it even worth it doing so? Because like, say I run my compiler, right, and I have different assembly for different platforms, right? If my language has like, I don't know, like context per compile time if statements, for instance, that will select different assembly depending on the thing, like will that work? Okay, let me ask Claude, how feasible would it be to design a language that starts at the machine code level and can be abstracted on top of to look like high level code? I'm envisioning a language such that you don't even need compiler specific optimizations. The optimizations are instead just deduced from how the language builds up instead. Obviously there are different machine code architectures, but this can also be recognized within the language via compile time conditional statements. No? Let's have a look. ZigC3 is exactly the compile time conditions for architecture thing. Comptime and Zig lets you branch on target arc/OS at compile time, and the same source can emit widely different code gen per platform. Fourth is the closest historical example of language built from the machine up. Words are literally composed from lower words down to primitive machine ops. No separate optimizer needed because the abstraction is the execution model. Okay. So inlining, constant folding, and monomorphization. Zig/Rust can solve this are free from the compile time evaluation generics, but it breaks down for optimizations that require global reasoning. So register allocation, instruction scheduling, vectorization, alias analysis. These aren't local consequences of how you compose the language. They depend on the whole function/program shape and target microarchitecture, which varies even within one ISA. They hand off to LLVM or similar backend for these because that reasoning doesn't compose cleanly from syntax. It needs a whole program IR pass. Your compile-type conditional idea works well for architecture selection, but doesn't replace the need for something backend like to do register allocation and scheduling once you've committed to primitives. Register allocation and scheduling. Like, my reasoning is, a compiler is written in a programming language. So why can't we move that compiler programming into the languages, well, into the language itself? Like, you have, I mean, like, and like the idea is that, you know, like, the programmer wouldn't have to write all these things themselves. Like, they would use the standard library, or other libraries even, to be able to use the language in the way they want to. Like, if I want to open a file, I would still have that abstraction done for me, so that I just have to open like a file, like class or something. But it's more that, like, if you then inspect that class and look into it, you will keep on finding ways it goes down to the machine level. I don't know, maybe it's not worth it. But like that's kind of like the ultimate language, right? Like, that would be the ultimate language. Well, in all but ergonomics, really. But then the question is, well, like, if you support that, how does that affect your high level code? Like, does it affect what ergonomics you can have? Because like you don't have too much syntactic sugar either. Like, you want it to feel fairly natural. Like, at what point does messing around with hydrogen and oxygen produce the water that we know and depend on? You know, the water that literally runs through our bodies. Like, how does that happen? And then at what point can we say, well, yeah, this is water. It's H2O, it's water. You know, like, abstractly, we just see it as water. We don't see it as molecules. We just see it as water. Difference there is the universe has water architecture, so that's quite, you know, that's quite handy. There's only hydrogen and oxygen, you know, that can compose a water. Like, that is water. Whereas on a computer, there can be millions of different instruction sets for fucking, I don't know, adding two integers, right? Like, that's not. And like, some things will support some instructions and some things just won't, and then you'll have to handle it yourself. Plus, on a computer, it's not just creating a substance like water. It is instructions. I have seen Forth. Isn't Forth a stack-based language? Yeah. Yeah, I've used it very briefly before, but it's hard to find good examples of the code. But yeah, like how would you like allocate different, like how would you choose which registers to put things in, right? Like, you need to have a way to dynamically do that within the language. Like, C has, or at least had, the register keyword, though I believe it's been deprecated now, so that you could specify which registers you wanted your function arguments to go in, and even like your local variables to an extent, right? Or, well, I mean, not which one, but like, you would declare that you wanted to be in a register, but then that's been deprecated because the compiler can do a much better job at determining that. But like, how does a compiler determine it? You know? And like, for a language to be that low level, it would probably need to largely, like, it would largely need to be very meta, right? Like, if a function call is performed in the language, how does it do? Like, how do you write that logic for how a function is called in the language itself? Like, that, this seems kind of cyclical, right? So how far can a mega macro assembler go? Function aligning, constant fault normalization. These are just macro expansion. Dispatch. Yeah, trivial, struct layout, call conventions, even basic loop unrolling. Okay. That's what I thought. So virtual allocation needs graph coloring / interference analysis across the whole function. Not expressible as local macro expansion, it's a global optimization problem. Yeah, I don't really understand graph. I mean, I know what graph coloring is, but for like function graph calling, function coloring even. Instruction scheduling depends on pipeline depth, latency tables, dependency chains across the whole basic look. Macros expand locally. Scheduling needs a window. Right. So a way to like kind of have the language communicate with its state, right? Yeah. Common subexpression elimination across expanded macros. Once two macros expand into overlapping work, you need a pass after expansion to notice the redundancy. That's an optimizer, not a macro system. Right. Right. Okay. Okay. So let's think here. So then the question becomes, how low level does a language go within itself, right? So like what basic constructs do you give? Like examples. Like for example, C has malloc to heap allocate, right? To allocate memory on the heap, I believe. Maybe you can also pass some custom allocator, but I don't believe you can. And like that's like a fundamental like operation. Like you need to be able to heap allocate in your language in order to interact with the heap. You can't really hand roll heap allocation because that's something that like the OS will decide for you, right? I mean, like through syscalls, I guess, but like, well, can you? Can you hand roll malloc? SBRK. What's SBRK? If fragments fast, right? So you can define malloc yourself. But there's a question of like why. And another issue with like designing a library, a standard library from the ground up, is that if the architecture ever changes, or like if there becomes a more optimal way to do something, the ripple effects are kind of massive. Like if you suddenly can't do something in a certain way, such that you need to change the interface for how it actually works, then that will like have implications on the entire language. But like, will it? Because like you can still control like how far the things propagate by having like flexible abstraction, such that the interface stays the same but the underlying mechanics change. Like that's still possible, though, right? What the hell is SBRK? What is SBRK? It asks a kernel to grow or shrink. The process is heaped by infinite bytes. Okay. And there's also mmap. So why is it that malloc isn't defined within C itself? C is a cause of the heap as language feature, only object to automatic, static, or architecture restoration. It's platform specific. Right. Yes, like this is what I mean. Like if you suddenly don't have the heap and you have a different architecture, like how are you going to write that within the language, right? Like you could have like different like have malloc be an interface, right? And then you can have like heap malloc, or like let's say some other computer architecture comes out with something called the shelf. I don't know, the shelf, right? And then you allocate to the shelf instead. So then malloc can also be represent shelf malloc or whatever. So you have heap malloc and shelf malloc, and then you call the one depending on what you want. And then for cross-platform code, you would say, okay, well, if I'm on this platform, then shelf malloc. If I'm on this platform, then heap malloc. Fuck. Malloc is a normal library function implementable by anyone, not a compiler built in. Without touching the language definition itself. Yeah, I suppose that's like another thing. If you have a standard library, right? Like yes, you can write, okay, like do this for this architecture, do this for this architecture, but if you do that, you have a problem, because then you can't write, like if you, let's say you don't use C. Let's say you are not a designer of the language and you want to make it support your platform. You can't do that. Like you'd have to modify this in a library, right? Unless the library is set up in such a way that it is modular and that anyone can contribute to it. But then you have like different, I mean, first of all you have fragmentation, second of all you have like different versions of the certain library, right? Like how can developer A add their support without conflicting with someone else who wants to add the same support, for instance? and like then like the programmer has to choose between all these different things for all these different things. I was like, I don't like, and like they're like, well, I don't care. Like I don't understand any of this like OS level stuff. Like I just want to make it work, right? You know, it's like, do you choose GCC or Clang or MSVC? You know, like it's, like ultimately they both pretty much all work fine. And like even between GCC and Clang, the differences are quite minimal. Clang kind of just like better, like has like better diagnostics, I guess, and uses the LVM backend. But like ultimately, the decision is kind of arbitrary. So you don't want programmers to be faced with that decision, because then they have to do their research on, okay, what should I use, or else maybe they'll end up choosing a wrong one, and then they have a bad experience because they chose the worst option, because they didn't understand what a good option was in the first place. So instead, having platform code just simply run on the platform depending on what platform it's on, and that is, you know, that is defined by the platform itself, then yeah, I don't know. Anyway, so okay, so like I said before, the question then is, how low do you go, right? How low do you go? So how low does C go? Like C doesn't go as low as memory allocation. That is not built into the language, or compiler built in. It's not. C doesn't. Well, C has syscalls, but like it doesn't. The syscalls only work. I believe syscalls are platform specific. Are syscalls in C platform specific? Because it's based on the OS, right? Yeah. Huh? Functions like read, write, and open are POSIX, not ISOC. Windows doesn't have them natively. Yeah, so syscall is a platform specific. Like, so at what, I guess the question then is, at what point does the code no longer be platform dependent? So syscalls obviously are platform dependent. But then if you, okay, so what's an example of the lowest level at which code no longer becomes platform dependent? It is a C ASHAP machine itself. Okay. Okay. So there is a question of just how low level this will go. For example, is it possible to go all the way to machine code? There's a but there, but I'm not sure what the but is. There's a question of how level this will go, but Yeah, no. There is a question wasn't months ago. For example, is it possible to go all the way down to machine code? Okay, so that's a question. Yeah. Okay, so there's that. So I think it makes sense to just start with the high level code, like the high level code that you would expect to be able to perform, and then go from there, right? Because realistically, programmers aren't writing super low level code most of the time. They'll be writing high level code for high level programs, unless you're writing like a, I guess like an operating system or something. That's when you would go more low level, but like Rust is a low level language, right? Even though it doesn't look it. And like same like C++. Well, I mean C++ has C though, so it doesn't count. But like, you wouldn't think Rust would be able to go like really low level until you look at low level Rust code. So in fact, let's do that. Thanks. Let's have a look at the. Did I click that? I don't know. Why did it show up? Let's have a look at the what's it called? The Linux kernel source. So we have the kernel. Now, 0.4% of it's in Rust. So let's see what that Rust actually is. Here's memory, right? I mean, it looks pretty inconspicuous. You have unsafe blocks. As you would probably expect. Which is a weird, yeah. It's a weird thing about Rust that you need unsafe blocks. Like, this unsafe code is actually safe, which is kind of funky. Like, I don't like how that's a thing. There actually really isn't much Rust code, is there? Let's have a look at, like, let's say string. It's weird. What's this for, I wonder? Your tests. Wait, format works like this? I didn't know format could take variables like that. That's weird. I mean, it's not weird, it's just strange. Yeah, it is strange. Okay. Okay, I'm not sure what that really gave me, but anyway. So, yeah, I'm not going to worry too much about the low-level stuff for now. Like, obviously, C exists, so that can be the lowest boundary, in theory, but... okay. Then there is the question of whether the language should be functional or procedural. Now again, the line between functional and procedural, I mean, functional languages, like, they kind of just have, like, rules. Like, a procedural language is, like, free programming, right? Like, because, like, assembly is obviously procedural. But functional programming is kind of just a restriction, right? But really, it's more so a question of how functional the language should be. As functional programming is really a set of restrictions on the programmer to write safer and easier to optimize code, right? So, like with purity, right? Purity, mutability, right? Or rather immutability, stuff like that. Higher order functions as well, like it must support that, otherwise it's not really functional. I mean, it's in the name, for crying out loud. Pattern matching, like all of these things are just like features, right? But like the main restrictions are no mutation, except there is mutation, and no side effects, except there are side effects. Like I find it hard to go with a functional paradigm when it literally breaks its own rules, because like it low-key has to. Like, you can't print without that being a side effect. And then that also makes debugging hell, so what do? They add another exception, which is the ability to print without it being a side effect. So like, it's like, what the, like, why? At what point just allow side effects, for Christ's sake? You know? Like, it exposes a design flaw. Granted, debug printing is different from non-debug printing, but still. So, the compelling thing about functional languages is that they can actually be easier to optimize. Or so I've heard. And it's why Rust, like, a lot of the time, it wants you to not use mutation, because mutation, I mean, mutation isn't expensive, right? It isn't, because you obviously have to mutate things at the low level. Like, that's what happens on a computer. But the compiler has an easier time reasoning about things when they are constant. So what are the benefits of a functional paradigm programming language over a procedural one? Immutability, data doesn't change unexpectedly, so few. I mean, also yeah, like mutation is also a side effect. By all means. Fewer bugs from shared mutable state. Yeah, shared mutable state, except if it's not mutating at all, then what the hell? Yeah, it's mutation, man. I mean, like, if I have a for loop, obviously I know it's going to increment. Like, I don't really need to restrict that. Like, there's no reason to restrict that. Really, it's for shared mutability. That's when it becomes an issue. So why are we making everything immutable as opposed to just making some things mutable? I wonder. Pure functions, same input always, giving the same output, no hidden side effects, easier to reason about and test. It's true. Pure functions are very useful. Like if printing can fail, then that's not very nice. But like printing can be made pure anyway, by having it return a result type if it fails, and then it is deterministic. Well, it isn't because it'll fail randomly, but like at least it doesn't crash, right? And like you can reason about it because like you can say, okay, this function might fail sometimes, and it fails under these circumstances, and that's still fine to reason about. But yeah, same input always gives same output. You know, in theory, nothing is pure because the OS can crash. But like in theory, everything is pure anyway. Like the input is just more implicit, right? Like it's a question of how explicit do you want to make the input, is what I'm kind of thinking. So pure functions. Oh. So pure functions is the idea of pure functions seem misguided to me. Well, it seemed to me as misguided, right? If you think about it, even impure functions are still pure, as the difference is that they just take their inputs implicitly as opposed to in their function argument list. Likewise, even pure functions are in fact impure, as it is impossible to control all the variables of a computer system such that procedures can truly be deterministic. Of course, there are cases like, I don't know, like bit flips and like cosmic fluctuations, whatever, that are not even worth considering because they are literally just either really rare or like so unrecoverable and so undetectable that there's no point. But like it does mess with this model of wanting pure functions, right? A reason that C is so annoying to write is that it has no struct member function. I mean, even then though, well, yeah, no struct member functions. But like, even then, like you can pass the things as arguments, right? All you really get with pure functions is more verbose function calls. and returns. Programming, functional programming. I'm surprised I don't have a thing for that yet. Functional programming. As a link. Functional programming. Huh. Funny. So, pure functions. Impure functions are pure. Easy concurrency. Yeah, concurrency is the biggest thing. Composability. Small functions combine clearly into bigger ones. Math functions reduce style, which you can do anyway, but okay. Better equational reasoning. You can substitute a function call with this result, like in math. Hold on. I guess the thing with composability is that in Rust you have like .iter.map because you're like defining an iteration thing. Like when I was using Haskell for the first time, I was under the misimpression that if I called like a map and then a filter, it would literally map and then filter, but it doesn't. It does them in the same steps. You just say that you want a map and a filter to occur, and then it will do that together. So I would literally create functions called like a map and filter that like try to combine them into one step before I realized, wait, that's literally what happens. And it's why Rust has .iter and then like .map, .filter, .whatever, and then at the end .collect, because that's what it does, right? Which is interesting. Better equation reasoning. You can substitute a function call with this result, like in math. Yeah, because it's deterministic. Passing functions as values enables powerful abstractions, higher order functions. Yep. Can be less intuitive for inherently stateful problems like IO and GUIs. Sometimes less performance due to minimal data copying. Huh? Wait, so it is less performant. I thought it was more performant, but it's not. Okay, well, that's annoying. Predictable code. Steep learning curve, yeah, whatever. Really functionality, not purity, should be opt-in, and it already is in like. I mean, yeah, like it already is in like in Rust and well, in Rust you have the mutable and immutable self, right, for a struct. In C++ you have const, which is basically the same thing. Like const methods, class methods. And of course then the function arguments can also be usable or not. But then you can call non-deterministic functions, so that doesn't make them pure, right? But yeah, the main benefit of deterministic is just that predictable. So if a function is marked as deterministic, it's predictable. Now the question is, when does it not become predictable? Like division is deterministic. Addition is deterministic. Even with overflow errors and whatnot, like those are still deterministic. And the compiler can very much even calculate those at compile time if it wants to. If it's able to, if it knows the values, right? It can collapse those. Okay. I mean, the main restriction, yeah, it's just functional purity and immutability. Those are like the main things that are imposed, right? And then you have like a lot of syntax that comes with that, but that will show a different story because you don't need to use functional syntax to have a functional language like that. But the main thing is immutability and pure functions. And then first class functions, but like that's a feature, not a requirement. So the key restrictions in functional programming are no mutable state. Well, are immutability and pure and function purity. I mean, do you opt in to purity or do you opt out of it? That's like another question. Like if you opt into purity, I'm trying to think. Like for example, the main function is impure. Both restrictions should be supported, but not forcefully. But not forcefully. I mean, forcefully imposed, but not forcefully imposed for all cases. Instead, you should be able to either opt in or out, depending on the defaults. Now, what are the defaults? Mutability by default, or immutability, or const or non-const by default, right? Like in C++, you end up having to put const everywhere because you have lots of things that are const. Really, the general philosophy is if you would generally forget to do something, and then forgetting it leads to worse performance or like worse results, then that thing should be the default. So like with mutability, you cannot forget to make something mutable because the compiler will tell you, right? But if you forget to make something immutable, the compiler could still technically warn you and say, by the way, this isn't modified, but that's harder to detect, first of all, for the compiler. And second of all, at that point, the compiler might as well just do it for you, right? But again, like it's more effort. And then it means that if you look at a variable in C++ and it's not const, you don't know if it is const or not. You just assume it isn't, because it could be const, but you don't know until you literally make it const. Whereas in Rust, because things are immutable by default, you cannot forget. Like if you see a mutable variable, it's possible that it will still be const, you know, and like not be modified. But it's more so that the programmer made it mutable anyway, so like they still had to make that conscious decision, right? So it's a lot less likely for them to make a mistake in that case. And you know, the compiler could still detect that a variable isn't mutated anyway, either during compilation or even during like a static analysis phase, which you do less often. Like it could still find that, but then that's just less hassle in general. And there's also a question of how often, right? How frequently do you make things mutable versus immutable? I have found in my experience that in C++, you have const variables way more than you have non-const ones. So there are a couple of reasons why variables should be immutable by default. So first of all, it's easy to forget to declare something as immutable, but you cannot forget to declare something as mutable if you wish to mutate it, because the compiler can immediately pick up on it. You are also less likely to mistakenly declare something as mutable when it is not, versus mistakenly forgetting to declare something as mutable. Mistakenly, Jesus Christ. Mistakenly forgetting. And what's the other one that I was talking about? Immutable variables are, well, tend to be more frequent than mutable ones in my experience. And it's a pain to put const everywhere. And for function purity, you ideally actually there's another thing, which is constants as well, because you have variables, right, which are either immutable or mutable, and then you have compile time constants. And the difference between these is that a immutable variable can still be assigned at runtime, so like its value is runtime known, whereas a constant value is in a compile time, so it can be folded into one value and then inserted directly. That is pretty much how that works. And it's useful to declare things as a constant, because then the compiler can like say, oh, okay, I'll fold this. Whereas immutable variables, like, so that it means that if you have a variable, it typically means that, you know, it varies throughout the program, right? Like that is the variable of the variable, that it varies between programs, whereas constants are constants between programs. That's the difference there. And then you have mutability and immutable, which just means that they mutate throughout the program, they change. So that's why the word variable can be confusing, because variable means to change, but in this case it's two different kinds of change, right? You have variables changing between programs and variables changing during the program, and one is mutability, one is variability. It's annoying that those are literally like pretty much the same term, but it's important to distinct. It's why I would not even really want to call my variables. I like a different name. So uh, what was my point there? Variables. Yeah. So the question is, do you have constants? Now, constants and variables are mutually exclusive, right? In that, well, not really. A variable can be a constant, and you just forget to declare it as constant, right? So there is actually an argument for having const be a default as well. So your variables are compile time const by default, and you must opt out of that if you want to have runtime variables. But that can be annoying, but it doesn't mean that you do not make the mistake of forgetting, right? Like in Rust, if I have let x equals 5, right? Like this has no reason to exist whatsoever. Like this should just be const. So there's also a question of put its defaults. There's also a question of how compile time constness should be dealt with. Mutation means change throughout a program's run time, whereas variability means change between program executions. A compile time constant is not a variable, as it is both immutable and does not change between program executions. Right? It is determined at compile time. Rust separates let and const, but this causes issues like let x equals 5, const x equals 5. Has no reason to not just be const. So one could argue that compile time constability, constness should also be a default. But then you can get goofy things like let var mutable x equals 5. Right. So this means it is mutable. The thing is, mutable here is redundant, because if it's mutable, then it's already not a const. And if it's variable, then it's that as well. Var here isn't even necessary because mute already implies var. The language could also just like not have const at all, like const expr, but I assume there's a reason that you want to have that. Ow. Why does Rust need const? Why not just have let and let's mute? Let always has an address. Okay, I should know that in Rust. Fathoming. Shadowing. Yeah, that's true actually. Shadowing is a thing. Although I'm not really a fan of shadowing. Like, I don't see it as necessary. Yeah, but I mean specifically at x equals 5 with the value 5. Cogitating. Are these words? Const is for values meant to be reused, documented, or global. That is, I did not expect that. Response. Except it isn't idiomatic because it's not, because it should be const. That is goofy. That is really strange, actually. Oh. Okay. Now, there's a bigger question to be asked here. What is the common point between them? Right? The common point between them is that they all are bound to an identifier. So for constants, you know, it's simply a constant. For variables, it is an address, right, in memory. And for mutable variables, it is a variable that can be changed. Odin comes to mind, because in Odin you just do this, right? You declare ID as 5, then it's a constant. But variables are different. But like functions are the same. You can have ID proc. I think you have ID struct, if I'm not mistaken. Why is it only one file? Yep, literally. It's quite interesting, actually. But variables are not. Variables are defined like this. It's different. And I don't know why they're different. Holy syntax highlighting? What's going on? Yeah. Some languages also don't have this, like a let mute. Some will just do like val, var, and I think that actually, which is also interesting. But what I don't like is how you can just forget to make something const. Like you just unwittingly write this, and it's like, now it's not guaranteed. Okay, hold on. But will X be created at runtime then? Even though it can be inlined? You said earlier that let guarantees an allocation. Guarantees. I don't know how I keep mistyping S as D. Yeah, so that's my issue though. Oh my god, but what the fuck? I mean, I know that code isn't like it's just kind of spewing what it's been fed, but like, what's it been fed, bro? This isn't logical at all. That's my issue though. Why would I not just use const and save the compiler? Why have const if not all constants are const and the not constant are const, and the compiler still has to look for the optimizations itself? Argentina's playing Egypt right now, apparently. Oh no, at 5 o'clock. Constant optimization solve different problems. Const is a language of a guarantee, no address, available at compile time, usable in const contexts. Optimizing away a let is the compiler being nice, not a guarantee. Now there is another benefit of not using const here, is that you can change it later to a runtime thing, right? Like, let's say I have player health, or like player max health, right? And say I set it to 100. If I'm making a game, like an early prototype of the game, I may want to make it non-const and just like a variable, because later I know that I will change it to be variable. But for now, it's not going to be variable. So in that sense, it communicates intent, right? Or let's say I have a magic number that I want to label, but I don't make it constant because that magic number could instead become runtime later on. Then again, I can do that. But also, like, why not just change that when the time comes? I don't understand. And like, why have const at all? Again, like, why have like const would communicate the intent that this is a constant, okay? So like, I don't know, what's an actual example of a constant? But also like, I don't know. I'm kind of lost on the on the logic here. But say you have a system like this, right? The identifier ID is a variable 5 of type, let's say I32. Well, no, probably the type first, right? So your ID is an I32. ID is a procedure. Kind of funky. I32 to I32. Here it is a struct. And the type is deduced. Here it is again I32, but it is specifically a var, a variable I32. But like, is that the type system? And here is mutable var I32. A constant is compile time. So why not just use const? where you can. I'm really not understanding this. Fathoming. I said where you can. I said where you can. So like if it's not const eligible, then don't. That's what I'm talking about. So does const guarantee inlining? A fixed reusable constant. Okay, so the semantics of constant Rust is that it is a reusable constant, not a throwaway value. But like, where's that coming from? Semantically, for me, it's always just been const means, or like const expert just means it's fixed and known at compile time, and can therefore be inlined. Like that's all I think about it. Meaning. Like why is reusable there in the requirement? I don't agree with that. Let me put these next to each other. Very interesting. Very interesting indeed. So, like, fundamentally, is there a reason to really have const? If the compiler can do it anyway? Like, again, like, I'm not getting that. Is const a useless feature? Like, again, like, if I have a static array, I may require a const parameter, right? And that's where that's useful, because I need it to be const, or else I cannot use it, right? So that makes sense. Oh, that's fine. It must be const. It must be const. It must be const. Yeah. So that's where you would want to have const, because if my array size needs to be const, then yo, give me a const value. Don't give me just any value, because I cannot guarantee this is const. And then like it's not clear if it's const or not, right? Like you could not have const there, but then it's like the compiler needs to like check itself, or like check like, okay, where is the non-const occurring? Oh, you have mutation here, or oop, you have a runtime provided value here, therefore this is not const, right? Or it can even be like in terms of like pure functions, right? Like getting input from the terminal is not pure, but if you are just taking input and output, then it is pure. So do you need const? Does a language strictly need const? Well, yeah, you do, because you need it for the actual array parameters, because the array needs it to be const. Otherwise, Doesn't work. Is that true? If my array because like it wants to be stack allocated, right? I was thinking, like, how else would you have that be a restriction on the array size without literally using const? You can't really, can you? Are there any other examples where you have fixed sizes? Or like fix anything for template arguments that isn't an array, or like doesn't like contain an array? Struct template arguments, right? Type T. Hold on. To be fair, there is a way that you can do it, which is have the array be well, it's a type, right? The array is a type specifically of type yeah, so like have the, is it just size, or am I tripping? Size and type. Yeah, so it takes a type. So it takes T, a type, N, which is a size, U size, let's say. And for type, it is, it'd be a capital T, would it? Because type is a type. Something like that, like TP for type, I don't know. Like FN for function, TP for type, or would it be a func proc type? And then the constructor would take a list of whatever's, right? So like say it takes args, or like elements, so like an anonymous elements dot of type T. Right? That's the constructor. Well, no, it's one constructor, to be fair. Yeah, forget the construct. Well, do you forget the constructor? Let's forget the constructor for now. I had struct syntax up here somewhere. Yeah, here. So these are your template arguments. And then you have your things inside. Yeah, but like then you have your details there, right? So the idea here, first of all, higher order types. The idea here is that if you put it in square brackets, it's const, right? It is a const requirement. Whereas if you put it in circular brackets, it isn't const. So like this is const for the type. Or I guess a better example is a function, right? So like let's say we have a function a function add, whatever. Let's say we have a function add 3, right? That takes a type again, t, and the function arguments would be so anonymous anonymous meaning like you don't have to name it in the function parameters, of type t, right? And it is simply just a plus 3. So then you call it like this. Or like this, I suppose. Whoops. Yeah. Right? Actually, I'll just include both anyway. That should be capitalized. So yeah, so what this does is that this has to be compile time known, right? Again with the array, an array is let's say like we have my array equals the array of type I32 with I don't know, like 10 elements, whatever. Okay, we'll do 3 elements, and then that's new with like 1, 2, 3, for example. So this has to be compile time, which means that if I have a my array size colon equals 3 by 32, which is I32 3. We'll just have this in the end, why not? Right, so then this says, okay, my array size is 3, and this works. This works because this is known to be compile time, right? Whereas if I had a get user input and this function wasn't pure, then this would fail. Sorry, this is my array size. Then this would fail. So what I'm saying is that this is how you would tell the compiler these have to be compile time constant, which is that it is part of the type information itself. Say for functions, it is part of the type information itself. So if I want anything to be compile time constant, then rather than having like a const whatever, I would just put it here. You know, like let's say I add 3 and I want to change 3 to something else, then I would just put that here, right? Rather than in this arguments. So if I'm not mistaken, the way that Zig does it is by having comp time. So if I'm not mistaken, Zig allows comptime in function parameters rather than having a separate template list, right? And I need to pee, I'll be right back. Yeah, Gal's right. So the reason that I don't like this, I don't like that you have to name things as comptime in Zig. I think it's cleaner to just have them be separate. Like I do actually like how C++ has them be separate. Hell, what's this? An array? Is this how arrays are done? You have the size first. An array of 5 elements, I32. Yeah, sure. Yeah, it unifies generics and compile time constants into one mechanism. I mean, I'm fine with having generics and compile time constants be the same by, you know, having types be values, higher order types, but I don't like how they're mixed. So rather than having to say comp time or const or whatever, you would just have them be here. And that's essentially what I've done. How does it work with structs? Where's Claude? How does this work with Zig structs? Stack is a function. That's a bit goofy. I mean, I appreciate it. I appreciate what it's trying to do, but I feel like this is not the most elegant way they could have done it by making stack a function when it's not. So comptime t type, comptime capacity, yeah, type. Types here as well for some reason. Is that the return type? Must be. Return struct. Wait, is it return type? Let me just check. That returns a type. That returns t. Yeah, it is. Okay. Return struct with items length const self equals this. Wait, so Zig has const as well. Why do you need at this? Why is that necessary? Then self item t void, so items, yeah, okay. Why is it necessary to assign this to self? Also, why does Zig have const as well as comp time? Is const just like different, like immutable? You could write this everywhere, establishes convention to make the signatures shorter, more readable. Okay, so that's just, so Zig just doesn't have that ergonomically for some reason. I guess to not have this be a keyword, but this returns the innermost struct enum union type being defined. So const is the value cannot be reassigned. Oh, okay. So yeah, so you do have const and comp time, and then var. And there's also var, compile time var, immutable value tracked during compile time execution, like a loop. Ooh. Wait, so there's comp time var. What is runtime const? Also, what is a comp time const? So comp time, I guess, just like isn't an actual keyword, like by itself. Sorry. Right. So comp time const is redundant, except it isn't. Okay. And comp time var is a variable that can only change during compilation, which is handy actually. Const is immutable, so comp time const is also unusual. Sorry, const is immutable, so comp time const is unusual. You just use comp time x equals. Well, that's weird that comp time can be used by itself then. So okay, so funnily enough, it supports comp time const, but comp time const isn't actually ever used, which is funky to me. So if you use this, it separates the need for an explicit like comp time. Like if this function didn't have that, like if it was more Zig style, it'd be like comp time t type and a of type t. And I would need to add an on as well here, but which is more verbose, but that's not really my main concern. My main concern is that then it's called like this. And there's not really a way to like deduce it. Like you can't just do add 3, 5 unless you can. Of course, you could make this explicit, but then like how's it deduced again? Like you don't really know. I mean, how's it deduced here? To be fair, it's not clear, is it? You could say that it's auto or something, which says that it can be deduced. You can even enforce that it be deduced, so that this no longer becomes possible, and you can only do 5 I32. That's another idea. In general, I was also thinking, when it comes to assigning values, there are 2 ways you could technically do it. Let me zoom in up here a bit, by the way. You could have ID equals, well, this, right? Equals 5. Or you can do ID colon equals 5 I32, right? But if you also don't need to literal, we can do I32 from. Or I32 like this. Calling it like a function, which basically just constructs it. Right? This just calls a constructor. So I mean, really, it'd be new. But wait, is formula highlighted in Go? Is new not? It is. Okay. So this or this. Now the question is, do we support one of these, 2 of these, all of these? You know, like ideally you'd only want to have one way to do it, right? And then therefore the one I lean towards is this way. Well, this way and this way, because if you want to allow literals, right? Well, you don't need to have literals. Technically, if you can do this, just that this uses more space, it might be a bit annoying. So but then like, do you not allow this? Because to be fair, this is already inferred. This can be inferred. Here I did like this, but really it'd be proc I32 I32 I32, and then that can be inferred now, the type. So that's also fine. Structure will have to be inferred, otherwise you just like have this, I guess, but you don't need to do that. And the type would have to be like you would still have to like name the type, right? Did I say struct? That should say type. I mean, this is just a mock-up anyway, so whatever. But yeah, so type like that. But then, like, how do I make it mutable then? Like, is it mutable ID? Or is it part of the type information? So I have a mutable procedure, a mutable type. Can I have a mutable 5? Oop. And I think there are other issues with this syntax as well. I can't remember now. Namely that it's not immediately clear that ID has a static type. It has to be inferred all the time. unless you allow the type to change. I mean, that's possible, right? It just means that the size can change as well. But like, if I want to in fact, that could literally be a way to implement dynamic vectors, or like arrays. Sorry, like reallocating arrays. But if I want to have ID have a mutable type. Sorry, yeah, mutable, mutable. Why is it called mutable, by the way? I don't like mutational. Mutable means something about like muting. I can't remember what it is now, or maybe it doesn't. I don't know. So yeah, so like if I have ID, if I want to reassign it ID to a different thing. So now, I mean, let me not think too much about the underlying, like the underlying mechanics of the like machine code. Let me just focus on the actual abstraction here. So I say ID is immutable I32. Why would the type change? Like, how often do you use different types, like types changing in like other languages? Like in Python, do you really use it that much? Probably not, I would imagine. I would imagine that the time it's most useful is in like arrays, you know, it's like as like a stand for tuples, but that has performance issues and means that, well, again, let me not think about performance because that can be figured out. So ID equals mute, and then let's say I want to reassign it to an F32, same size. And I probably wouldn't have this type protection anymore. Mutable should really go like here. Really. This just means that it can be reassigned to. That's it. If it doesn't have this, then it's constant, and it cannot. Well, it's immutable. You could like var like this, I guess. Var I32 5, but that's even more verbose for like no fucking reason whatsoever. And then like, what's an anonymous value? What's an anonymous variable? It's literally just a function. So, what the fuck? An anonymous variable is just a value. So like, there's literally no reason to do that. So that's redundant. And then this doesn't make sense there, so this has to be like this. Right? And then, sorry, so then you have var for, yeah, but let's say I don't have this, that var mute thing. Let's say, again, I just use square brackets for constants. So then this is just a normal variable that is immutable. And I say I32, 5. But then how do I have like the type parameters here? Right? And then like, how do I have nothing? Like if I like if I just want to have ID be uninitialized, I can't do that. Like I32? Like that doesn't really work. A variable I32? And like later ID equals 5 or 4, like it's not really great, is it? So to that extent, you do want it to be, yeah. That's it. That was like that's the reason that this doesn't really work. So let's just forget that. So then we want this, and then these are possible, and these are all possible. I mean, these ones you could argue between. So like, you don't have to have it be new. You could just have different, like you could new like just be implicit there. So then we remove that. What the fuck? And then all of these remain possible. And the decision really just becomes preference even. Type deduction is definitely useful, so I don't want to get rid of that. So, yeah, okay. So then, oh, there you go then. So then your variables, let me merge these now. So variable would just be like that. If you want to be immutable, you have to say immutable. Did you put it there? Probably not, because like you wanted to deduce a type, right? Really? No. Yeah, mutability should not be part of the type. It should be part of the identifier. So mutable my var. Or at that point, just var my var. It can change. Ooh, sorry, but this idea of having compile runtime constants, no, compile time variables, that's really interesting. So how would I have a compile time variable? Whatever, yeah, compile time variable. I mean, I can have like runtime and compile time, right? So comp and runt. The fuck? Comp time and runtime, for instance. And then if I want to reassign it a compile time, I can, if and only if it's very interesting. So how could this work? So compile time so in Zig I'm guessing it'd be comp time var first of all. Right? So comp time var, which means I can change it. Ah, dude, why is my heater giving me electric shocks? It's actually really annoying. I'm gonna cover it with something. Like I sit right next to it, so it happens really often. It's getting on my nerves, literally. Sort of like it. So comp time var my var. And then we can reassign it, right? So my var equals 3, and that's fine. But let us assume instead that comp time is well, no, it can't really be implicit, can it? Like, how do I unify this syntax with this syntax? And I'll remove this because this is Zig. And you know, it was like this, right? So let's first remove these. This looks wrong. So we have mutable or var. So var my var. So just put it here instead. So my var var, have it there instead. Which I lean towards just because I'd rather have the identifiers be on the same line. So my var var equals this. That means I can change it. And then just have the compiler implicitly keep track of which one, I mean implicitly, but like have the compiler keep track of which ones are compile times, constants, or like known at compile time, and which ones aren't, right? So say if my array size equals this, right? Now let's say I were to make it variable, and then later say that my array size equals 5 instead. Okay? So now, this is different. But it works at compile time. That's fine. Oh my god. How'd that happen? Right. Like this works, right? So then compile time is just implicit. Like whether or not it can be compile time known is not something you have to think about. It's just it's for the compiler to do. And then if I ever change this to not be okay, but here's the thing though. If I change this then and say like okay, it's plus some get dynamic input or get runtime int, right? Like let's say I do this. Now suddenly this fails. Okay, this is the wrong place for it. Like this would be fine, but if I did it here, even just this, right? If I did it here at runtime, now I have an issue. Now this will say, whoa, hold on a second, my array size is no longer constant at compile time, so you cannot use this anymore. Why is that an issue? Because it means that I can unwittingly change a variable which doesn't seem like it would be a problem, and then get a bunch of errors suddenly. And that can be particularly problematic for like libraries where I have constants that are surprisingly end up just changing to not be constant anymore. It's like, oh shit, that's not constant anymore? Are you serious? Because there was never a promise that it would be constant. You see what I mean? That's the issue I'm seeing here. So, to that extent, it is useful to have an explicit compile time keyword. So then I can have still var, but like, what do I do? Like comp var? I guess. I mean, it's not a bad idea. Or have it like this, var, which to the untrained eye looks like an array, but it's not an array. It's a template argument. Arrays would use it a different syntax. So now this says var and must be at known compile time. Ooh, but then like what if it's not variable? Then I just have this, which looks kind of goofy. Like my array size constant. Like what? I'm aware that var and val are two possible things, by the way, but so let me revisit this. What's our issue? We have var. So we have in Zig. We have in Zig there are. What it is, so you have runtime var, right, which is variables that can change at runtime. You have runtime const, which is variables that are constants. Let's just say they're like IDs that can change at runtime for like identifiers. IDs that cannot change any hold on. IDs that cannot change once assigned at runtime. Then you have comptime var, which is IDs that can only change at compile time. And then you have comptime const for IDs that can not change whatsoever. IDs that cannot be changed once compilation begins. Well, cannot be changed from the start of compilation. What? IDs that cannot be changed ever at all, right? All of these are genuinely useful, except comptime const isn't really used in practice, as it is treated as redundant, considering the compiler can deduce if it needs to be. Wait, there's also comptime, right? Except content cost, is unnecessary, as you can directly comptime x equals instead. I mean, in C++ you have const expert const as well, but then you can also just do const expert, and that's also fine. So like, it's kind of weird, right? Like, why is comptime const possible? It makes you wonder why comptime const exists in the first place. And ideally, it shouldn't. So how do we set up our runtime versus comptime and var versus and variable versus constant syntax without having redundancy? So what's the issue? The issue is that comptime implies const, right? So the core issue is that comptime implies const. Well, no, it doesn't. It literally doesn't, though. Why does Zig let you just do comptime x equals. This doesn't have to. It's also a thing, a block. I feel like comptime isn't needed for scoping though. So you're forcing a loop to unroll a compile time, or you could use a function, and your code would probably look a bit more sensical, or like nicer. Or use like a lambda that is comptime. But then like what does comptime even mean? Pure. Really, it's pure. Comptime and pure are not the same thing though. But it's more that a pure function can be called in a comptime context. Doesn't have to be, but it can be. So and then like what's the default as well? Is a default comptime or runtime? Because right now this is runtime, not comptime. But if I have to explicitly make it called runtime, or like run, I mean I don't want to call it run though. Runtime var or comptime var. That can get annoying though, because like then everything has to be called runtime, doesn't it? Like, do you want everything to be called runtime? In this case, well, we can simply just not have comptime as anything but a modifier. This way, but a modifier. This way, comptime by itself means, well, we can simply just not have comptime be usable outside of identifier declarations, unlike Zig, which allows its use in many other contexts, and then have const be implicit such that comptime x is in fact comptime const x, and comptime var x is explicit. A constant is a comptime constant. Is explicitly a compile time variable. But should comptime be a keyword? Be the explicit modifier? Or should runtime? Right? The same argument, well, Part of the same argument for why variables, for why identifiers should be immutable by default apply here too. Except that comptime, compile time identifiers are arguably a lot more rare. Well, are a lot less common, and therefore too tedious, and therefore, well, are a lot less common than runtime ones, and therefore, and would therefore arguably be more annoying, quite frankly, or like be more verbose, be annoyingly verbose. So yeah, so do we have my, so let's say you have my var, right? So you have runtime, we have my var runtime var, we have my var, I mean at this point it's not going to variable anymore, is it? Say foo. Foo and foo var. Right, so we have runtime variable, what the fuck? Runtime constant, compile time constant, compile time variable. And finally, variables are in fact variable. The game is on. So yeah. So it's that or comptime. So option A, or exhibit A, I don't know. Or option B. Such a big gap between these two. Why is that? So option B would be runtime, comptime, comptime. Yep. I mean, one way to mitigate this issue would be to use different keywords. So what are some alternatives to the keywords comptime and runtime for a programming language that are less verbose? I feel like const. Run though is pretty good. I mean, run is okay, but like it just I don't like how it reads like a verb, like run var. What are other words for runtime in general, or like compile time? Like compilation versus execution stage. Below like exec time. Like the reason that runtime, like like the reason that run is like a verb is because it literally has like the word runtime has the verb in it. CTRT. I already thought about that, right? Compile time, runtime. But I feel like it doesn't make sense to have RT without CT. I mean, yeah, you can, or vice versa. I mean, comp is honestly fine as well. Stat or dynamic. Static is not really accurate, and dynamic you probably want to save for other things. Meta. Okay, so why is it that runtime is the default? Yeah, okay. So let me just delete option A, because it's actually not even like a consideration. Thus, it does make more sense to have comp time be the default. Plus, we can use a more terse name. Well, plus we can use a shorter keyword. So you have comp var. Yeah. Now the syntax highlighting makes it not look great, but with syntax highlighting, it will look better, right? So you have foo var, foo comp, and foo comp var. And comp is a restriction. Comp. I mean, compare though. Or even just CT, like var and then CT for compile time. I don't know why it just feels wrong. Is there something else?
Years. It is in a single World Cup game as well.
Ronaldo. My issue with comp is that like runtime, like run, compile, whereas a comp can be like compare, which isn't great. CT feels wrong because the other keywords in the language are like, func for function, type for type, proc for procedure, but then you have CT, compile time. It's like, what? Huh? Like, why do you use the abbreviation there? I mean, you could also use shorter names for the other ones, like func, have func be FN, type be TP, procedure be PC. That's even if I have func. In fact, let me remove func as a keyword. Should be proc. Should be proc. And if it's pure, it should be a pure proc. Or something like that. In fact, should things be pure by default? Should probably opt out of it, right? But then like func and proc are just so natural in that case. So probably just keep func, to be fair. Yeah, so then you have var type func CT. I mean, comp would make sense, wouldn't it? CMP for compare. Var is just for variable or variable. Why does it feel so wrong? I don't understand. Compile time constant. Right? Compile time. What are some other words for compile time in general? Like in English? Bro, if you're in Chinese, like, just use like symbols. In fact, you could create symbols. And like the Chinese government could do that. Static, pre-compiled, build time, ahead of time, pre-run time, okay, fixed, predetermined. I like fixed, except it sounds like it doesn't change. Like, how do you allow change if it's fixed? It's not fixed. It is just, it's calculated. It is resolved. It is known at compile time. It is known at compile time. That's the word. It is known. The value is known at compile time. So how do I express that? Known. Known? Like KNOWN? No, probably not. How about something that conveys known at compile time? Because like that's really what it is, right? Static precompiled horizontal build type, like builds, but that's also just weird. AOT for ahead of time. Attack on Titan. Like what time though? Static. Known, fixed, resolved. Result's actually pretty good. Res is like looks like result. RSV, reserved. Not great, is it? Const just isn't correct though, because it isn't constant. It can change. A const var doesn't make sense, but it's something that can happen. Early bound, weird. Baked in, weird. Static. What is, like, static means fixed. Static means fixed. Yeah, fixed in place, unchanging, or stationary. I'm specifically looking for something that doesn't imply unchanging, because you should be able to have compile time variables. Resolved, early bound, derived, staged. Staged. Staged is pretty good, actually. If not, again, verbose. Staged. Stag. Staged. The scary thing is, like, there's not guaranteed to be a good option. It's kind of just the English language, isn't it? Stage is so bad though. Foo staged, var. Foo var. foo staged, stage foo, var foo, stage foo, comp foo. Okay, I'm gonna go with comp for now, and that may or may not change later. But for now, let's just go with comp. Okay. Okay, this is nice. So then, notice how the keyword is attached to the identifier, right? And it's attached to the identifier, not attached to the value or the type of the value. Although arguably it should be part of the type system. Right? Let me change these to the actual syntax stuff for the language. Yeah, I like how this reads. Foo comp var at equals 5i32. Where at equals just means like type deduction. So like really it's just equals. It's 5. Five. And if you just write it out with the full type, what'd you get? Foo at i32 equals 5. Foo var at i32 equals 5. Foo comp at i32 equals 5. And foo comp var at i32 equals 5. Foo comp var at i32. Thing is, the type is static anyway. Compile time i32. Compile time variable i32. Like, I'm trying to think, where does it make sense to put it? Say for here, for like function declarations, I'll put this up. Like, this has to be a compile time. So this would already be a comp anyway. A comp, right? But like because it's inside the brackets, it's implicit supposedly. So then we don't use it here. We only use it in function in identifier declarations. But for these we don't do it. For these we simply have this and then this. So let's suppose we were actually to remove the square brackets. Perhaps. So it'd be add 3 equals a function which takes, again, an anonymous deduced, right, auto t. Okay, can I do dead for deduced? Infer t at the type, and then an anonymous a at t. and that is not comptime known. But it can be comptime known. This is the thing that, like, it can be compile time known, or it cannot be, but like it doesn't require it. This only requires it because it's a thing argument. Yeah, okay. And then yeah, just a plus 3. And you just call it like, yeah, 5 at 32 is reduced, right? T equals I 32. Like say like instead of anonymous, you have infer instead. So for inferred ones, you can optionally type it if it's not inferred, right? For named arguments, or even just like at that point just have a default, right? Equals like type of A, but like A isn't known at this point, and then and like then it's like circular, right? You have anonymous A of type T, and then this. Very strange. Like, how do we communicate that T is automatically inferred from A? Also, can the type be inferred for a function taking a type parameter? Any type. Yeah, so you type of A here. So then instead of T, you don't have T. You just have an anonymous A of type auto, say. And the return type would be type of A, which could be written as at A. It's interesting because in C++, when you have the auto keyword, it means that you don't need to make everything use templates. Like C++ is like implicit template deduction, right? Is implicit template deduction bad? Like, if I were to have, in this system, add 3 I32 and pass like 5 as an I16 or I8, then this would implicitly cast, right? Implicitly cast this to this because it's a Whiteton conversion, so it's fine. Well, let's assume. Then you could do that. I don't know though. And then how do you construct the array? I guess you can still keep these anyway, but then these have to be comp anyway. Like they have to be comp. They can't not be. So that just seems redundant. Because we're already using the square brackets. So like you could still have the square brackets optionally, I guess. But then again, but then you have two ways to do things. Like in functions, if you allow function arguments to be comp time, then yeah, oh no, I'm not a fan of mixing the comptime arguments with the runtime arguments. Because if it's not a compile time, why does it even exist? Like, at that point, you just use it for overloading or generics. So just have generics like this. But then it's just hard to unify with this. Like, why is comp a keyword here and not anywhere here? Even though var can be a keyword here, right? Like, you could have a be a var. So then if I want to change a, I can't, right? I could say instead it's variable, so I can say a plus equals 3, and then return a. And now a is var instead. Also, like, there's things about like copying as well that I haven't really talked about yet. Like it being a reference. So really, var should be on this side, I think. And then if it's like a reference, it's like that, right? Or a mutable reference, whatever. And then have mutables to be a thing there. Or, well, no, yes, because ref would also be the thing here, right? So let's move these to the type. I mean, here's obvious. You just put it there. A var i32, a comp i32, or maybe not. I'll have like this instead. So I have a mutable i32, a mutable i32. Comp mutable 32, and then the comp can only be used here. And then for here, what you do? Just var like that. Like var auto. But then like if I make it mutable, I have to like fucking put var before it. Like that, and that's annoying. Like var has to be here. Or here. Like that, I don't feel like is really negotiable. But then this is just so convenient. Because then like for compile time instead, I can have this. So it has a compile time i32. That's still weird, because it's like, why is it like that? And like, then I can do this, right? But no, you can't do that. So really it should be like this. Hold on, chat, let me cook. What's the, let me cook. Now that cannot be cooking. So yeah, putting it afterwards just isn't really feasible. Man, this is way harder than I was anticipating. There just has to be a solution. If you remove the at sign, it becomes messy. At the same time, not really. Like it is, like it does work. But it's just like less like visual separation here. Like auto T type. No. Um, like for arrays, like you could have this, right? But it doesn't feel right. Like, are you gonna do arrays like this? Or like this? I mean, anything that's a... well, no, actually. Well, kind of. Anything that... well, no. Ah, fuck me. Okay, I was gonna say that anything that takes a type, like any type parameter or argument must be comptime, but that's not true. I don't think. At least I doubt it has to be true. It's just that like these have to be compile time anyway, just for the sake of creating an array. Like these have to be compile time. So like because it's part of the type information. Like the type has to be known in compile time because it's a cyclically typed language. You can't just have an array of a variable size, like a runtime known size, because then it can't, the compiler can't write the assembly accordingly, or have to heap allocate, right? Which is why I lean towards this syntax, just because it's explicitly like, if it's in square brackets, it must be compile time. So then the issue is you have the comptime keyword, but why do we have the comptime keyword if we don't need it? because we have square brackets. So then you say, okay, then well then just have comp be limited to here, this use case, and that's fine, except then mutable is used in other places, right? So why is that used elsewhere? That's kind of weird. In fact, we need to use it in function arguments, our parameters, because we're also declaring functions things here, right? And even like instructs, right? Like a struct would want to have fields that are variable and others that aren't. What? Argentina has had 7 shots with 3 on target, and they scored 0 goals. Egypt has scored 2. Sorry, has had 2 shots, 1 on target, and the 1 went in. Bro, Argentina's goalkeeper, man. Passes. Damn. 8 fouls? What the fuck? Yellow cards. Not a penalty, is it? Doesn't say penalty, no. He scored it in the 15th minute. 0 offsides. There's 1 offside. Okay. God damn. Okay, well, okay. I'm gonna eat and probably watch the game, and I'm gonna come back to this later. But so far, what have I achieved in these 3 hours? Not much. I've been stuck on this for 3 hours on my days, but yeah, I'll come back to this and I'll think of something. Yeah, it's interesting. So it's definitely important because like what I want to have is again intuitiveness, right? So if something is constant here, like if I use this keyword for this thing, I would expect to use it for this thing here as well. If I don't need to do that, then that just comes across as weird. Now you can make why these lines are prominent now? I need a new camera. Like I can make exceptions, right? For when I don't have keywords be the same. But like I want it to be consistent, right? Consistency is very cool, and I feel like there just has to be some paradigm, some way, some syntax where it makes sense. So I'll keep thinking about it, and we'll see if I can come up with anything. But yeah, we'll keep seeing. We'll keep marching on. I may even. Yeah, I have some ideas formulating, so I'll think.